So we want to handle the big data using distributed computing. What exactly is distributed computing? So let us try to understand what is distributed computing. So we have the overall final task. What we can do is we can divide the data into smaller pieces and place them on all these different machines. Now these smaller machines or low end machines can handle smaller data sets. So we have a huge data set. We can divide the data set into smaller pieces and then distribute it onto all these machines. And then we connect all these machines using LAN or WAN. And this whole set of machines or cluster of machines, cluster of computers look like a really big supercomputer. We can make it work like that. So divide the overall data into smaller pieces, put them in each of the machine. Divide the overall problem into smaller pieces and then run them locally on each of the machines. Let us try to understand what exactly is divide the overall problem into smaller pieces. Let us suppose we just want to simply find the number of lines, or in a particular day, let's say the data is from Facebook. In a particular day, how many likes are there in Facebook? That is what we want. So we have the huge data set of all the likes, so that is in TBs or something, or petabytes. We divide the data into smaller pieces. Let's say represents each row in that data set represents one like, or each row represents one activity. If we want to count the number of activities, we can divide the whole data set into smaller pieces, put them on all these low-end computers. Now overall problem is we want to count the number of activities. So we can divide this overall objective also into smaller pieces. So we first count the activities in computer number 1, whatever is the data on split 1 or data chunk 1. We can calculate the number of rows, or we can calculate the number of activities. We can individually calculate the number of activities on all of these systems, and we can do that parallelly also. And then once all these systems are locally calculated, once all these systems have locally calculated the number of rows or the number of activities, we can simply add them up later to find the, or to fulfill, to get the final answer. So what we do, we divide the data and store them locally, okay, and then on each of the data we run the task. So this is called map. So on local systems, on at the map level, or at the very low level, we are calculating something that is called map. Once we get the output of the map, we collate all of them and calculate the final answer. So in map we find the count of, let us suppose, let's take this as a simple 3 node cluster, 3 nodes, 3 computers. So we divide the whole data set into computer 1, computer 3, computer 3, computer 1, 2, 3. We take data chunk 1, piece 1, we calculate that. Parallelly we can calculate the number of rows in piece 2. We can calculate number of rows in data set 3, or the third part of the data. This is called map. Once we have the result of all these maps, then we can calculate reduce. That is nothing but the sum of all these rows, okay. So this is nothing but the distributed computing model. So you divide the data, you store the data locally in a distributed manner, you achieve your final objective also in a distributed manner, and this type of programming is known as MapReduce programming. Why it is called MapReduce programming, or MapReduce and network programming? So what is map? So at the low level, this is the low level computation. You go to the each and every data set and data chunk, wherever it is, you calculate something. So that is called map. The output of map is the not final output. The output of map is the input of reduce. In fact, for map process, what is the input? The original data. The original data is input for map, and map will give some intermediate output. Reduce will take that as take that intermediate output, calculate something over it, and then finally give you the result, okay. So we process the data using special map and reduce functions. So map function is run on each and every input. So simply we calculate map on each and every input, and then that will give some intermediate value. That is, map is nothing but the local calculation map. Then reduce is kind of on the intermediate values, reduce function will be called, and reduce will calculate the final value, or the final result will be given by reduce. So since we can't handle the huge data set, big data, using normal computers or conventional tools, what we are doing is we are making use of distributed computing. What is distributed computing? You distribute the data first, and then you split the overall problem into, in a way you can code it in a MapReduce format. In fact, MapReduce is not new. So finally, if you want to make something, if you want to achieve something, you don't need to do it in one go. You can divide the whole problem into different pieces. That is, initial data is this one, raw data, and then you get the intermediate outputs, then you do the reduce. So this was there, I mean the idea was there earlier. Now with the network programming and all that, network computing, we can achieve MapReduce distributed computing. So what is the conventional program? Let's say, let us once again revise this MapReduce program. What exactly is MapReduce? Let us suppose if you want to find the number of rows in a huge file, the file size is 20 TB or something. So if you want to find the number of rows, how a normal program, how will you write in a Java or C++ or any other program? You will write a program which simply says count equal to count plus 1. You go to first row where count equal to 0, then you go to second row, count equal to count plus 1, third row, fourth row, like that. You do it in a one by one manner, and then finally you will get the result, final count. Once the number of rows are, total number of rows are finished, count will come as output. But the same problem, since now the data is not existing in one particular machine, since we don't have a supercomputer, now we are doing distributed computing. What we do, the same problem, the same objective is achieved in a MapReduce programming model. So this program, though we just want to find the number of lines, here we need to write it in a different way. The program need to be written in a map and reduce format. What is map program here? What is a map function? Map function will be on each of the pieces, count the number of rows. That will be simply count equal to count plus 1. So on piece 1, count the number of rows. On piece 2, count the number of rows. On piece 3, count the number of rows. Like that, you count the number of rows on all the data pieces in each of the sheets. Then what is reduce? Reduce is not simply taking the input and then the count. Reduce will be sum, because in piece 1 there are 10,000 rows. In piece 2, let's say there are 20,000 rows. In piece 3, 15,000 rows. What reduce will do, map will give this as result, and reduce will take all these 10,000, 50,000, 20,000 numbers, and then it has to add it up. So reduce program will be count sum, so it has to sum up, it's not count. So the overall problem, count the number of lines, is converted into map and reduce format. Map is simply count equal to count plus 1, whereas reduce is count sum equal to count sum plus sum. Basically you're summing up. So we are converting one line program into two line. Basically we are converting the usual program that will run on a single node into a distributed manner. This is called map reduce programming. To handle big data, we need to write map reduce programs. We can't write simple programs. Why we need to write map reduce programs? Because the data is distributed across nodes. It is not in a single system. Is that clear? So that is the MapReduce introduction.